So yesterday we stopped till alkyl halides, preparation of alkenes from alkyl halides. That is till the dehydrohalogenation, beta elimination reaction. Okay. Now the third method of preparation is from vicinal dihalides. Vicinal dihalides. Halides means what? Halides means halogens. Dihalides means what? Two halogens. Vicinal position means those two halogens will be in the next carbon. Okay. If one halogen is in the first carbon, the other halogen will be in the next carbon itself. So those type of halides are called as vicinal dihalides. So from vicinal dihalides, how it is prepared? For example, CH2, CH2, Br, Br. So this is an example for vicinal dihalide. Okay, plus zinc metal. What will happen? One bond will shift here. Okay, and the other bond will form a bond with zinc. So what you will get? If one bond shifts here, you will get CH2 double bond CH2 plus ZnBr2, zinc bromide, salt will be formed. Okay, suppose if it is propene, how you will get? Br CH2 Br. So if it is like this, you will be getting propene. Okay, so this bond will shift here. So you will get CH3, CH double bond CH2 plus Zn Br2. Understood? So this is how it is prepared from vicinal dihalides. Next, from alcohols. How they are prepared from alcohols? From alcohols, they are prepared by a process called dehydration. Dehydration occurs. What do you mean by dehydration? Hydration means adding of water. Dehydration means removing of water. So from alcohols, if we remove water molecule, what we will be getting? We will be getting alkenes. Okay, so dehydration will occur. So dehydration means removal of water from alcohols. Dehydration means removal of water, but here we are going to remove water from alcohols. Okay, we are going to do this in the presence of acid. We are going to do this in the presence of acid. Mostly we will be using concentrated sulfuric acid. Already this concentrated sulfuric acid you have studied in your 10th standard in carbon and compounds lesson. Okay, in esterification reaction you have studied. Okay, esterification, saponification, did you study all those reactions? In that concentrated H2SO4 you would have studied that it is a dehydrating agent. Have you studied or not?
Yes, sir.
Dehydrating agent. Dehydrating agent. Oxidizing agent means what? The substance which adds oxygen. Similarly, dehydrating agent means the substance which removes water. Okay, removes water. Dehydrating. The substance which removes water is called as dehydrating agent. So dehydration is happening in the presence of acid. So it is called as acid dehydrogenation of alcohols. Acid dehydrogenation of alcohols. So we will see that. So for example, I am going to take an alcohol CH3, CH2OH. What is the name of this alcohol? It is ethanol. Okay, so how I am going to write this? You see, the CH3 I am going to write like this. Okay, bond, the CH2 I am going to write like this. CH3, CH2, this OH I am going to write like this. Okay, this OH I am going to write like this. Now what I have to remove? I have to remove water. For that what I need? I need concentrated H2SO4 and I have to heat it. So water, here H is there, here OH is there. So this H and OH should be removed in the form of water. So what will happen here? You see this bond will shift here and this bond will be formed between H and OH. So what you will be getting? CH2. You will be getting, already one bond is there. Now this bond also is coming. So double bond CH2 plus what is getting removed between H and OH, bond is forming. So H and OH is nothing but H2O. So this is the dehydration. I have written dehydrogenation. Dehydration of alcohols, acid dehydration of alcohols. So if it is ethanol, I will be getting ethene. If it is propanol, I will be getting propene. Okay. So whatever is the alcohol, the corresponding alkene I will be getting. Understood? So these are the 4 methods of preparation. Okay. Next, we are going to study about the properties of alkynes. In that, first we are going to study about the physical properties. Write down. The first 3 members are gases. First 3 members are gases. What do you mean by the first 3 members of are gases? What are the first 3 members in alkenes? Ethene, propene, butene. In butene itself you are having but1ene and but2ene. So these members are all gases. Okay. And after that the next 14 elements, 14 alkenes. So from pentene to the 14th element till pentene. So the next 14 alkenes are liquids, whereas the higher alkenes are solids. Higher alkenes are solids. So they have given the properties of ethene. Ethene is colorless gas with faint smell. What do you mean by faint smell? Don't write paint smell. Faint smell means what? Huh? Bachelor. Faint smell means very, very mild smell. Okay, but it will be having a very sweet smell only. Sweet, faint smell it will be having. Okay, and only ethene will be having smell. The other alkenes are odorless and they are also colorless. Colorless and odorless. Okay. So these alkenes are insoluble in water. Why they are insoluble in water? I told you carbon and compounds are non-polar. Non-polar means what? They will not have positive charge and they will not have negative charge. But water is a polar solvent. It has H plus ion and OH minus ion. So non-polar substance will not dissolve in polar solvent. Where it will be soluble? It will be soluble only in non-polar solvents. Non-polar solvents. Okay, so non-polar solvents means like ether solution, benzene liquid. So it will be soluble in these types of liquids. Okay, but it will be insoluble in water. Now, so first one is ethene, you know. The next one is propene. Next one is butene. Yes or no? So they all belong to one homologous series. Yes or no? So what will be the difference in the chain length? Each alkene will differ by chain length. I am asking, not mass. They will differ by a CH2 unit because they belong to the same homologous series. So ethene will have 2 carbons. So propene will have 1 CH2 extra. Okay. So they will be differing by a CH2 unit. What will be the difference in mass? Yes, difference in mass will be 14 units. This and all you have studied in homologous series itself. Okay. And when each CH2 increases, the boiling point also will increase. Okay. Each alkene will have increase in boiling point. Will have increase in boiling point. So increase in boiling point means what? Ethene will have the lowest boiling point. Okay, propene will have little bit higher boiling point. So when the CH2, number of CH2 when it increases, the boiling point also gradually increases. So the boiling point increase will be around 20 to 30 Kelvin. Okay, so the boiling point difference will be around 20 to 30 Kelvin. Okay, they also can form isomers. They also can form isomers. Understood? So these are the physical properties of alkenes. Now we will move to the chemical properties of alkenes. Chemical properties of alkenes. Chemical properties of alkenes. So the first chemical property is addition of hydrogen. Addition of hydrogen is called as what? Addition of hydrogen is called as
Adding of
removal of hydrogen is dehydrogenation. Addition of hydrogen is hydrogenation. So addition of hydrogen is called as hydrogenation reaction. Okay. So we are going to add hydrogen where? To alkenes. This already you have studied in your 10th standard in addition reaction in carbon and compounds. Vegetable oil to vanaspati ghee. Do you remember that equation?
Yes, sir.
Okay.
Yes, sir.
So CH2 double bond CH2. If I add one hydrogen, okay, what will happen? Tell me. If I add one hydrogen, what will happen? One hydrogen will be added this side. Another hydrogen will be added this side, and the double bond will change into single bond. So what I will get? CH3 single bond CH3. What is the catalyst? Nickel catalyst. Nickel or platinum or palladium catalyst. Next one, addition of halogens. Addition of halogens. Addition of hydrogen means it is hydrogenation. So similarly, addition of halogen means it is halogenation reaction. Halogenation reaction. So we are going to add halogens to alkenes. So simple alkene we will take CH2 double bond CH2. I am going to add a halogen bromine. Okay, so for adding hydrogen we need nickel catalyst. Okay, similarly for adding halogen the catalyst is CCl4. What is CCl4? How many chlorine is there? 4 chlorine. So it is tetrachloro. How many carbon is there? 1. So it is tetrachloromethane. So that is a solution which we are going to use as a catalyst. Okay. So hydrogen, how it got added? One hydrogen this side, another hydrogen this side. Double bond changed into single bond. Same way. Here what will happen? One bromine will be added this side, another bromine will be added this side, and double bond will change into single bond. So what I will get? CH2, one bromine will be added this side, double bond will change into single bond, and CH2 Br I will get like this. So I told you in the beginning of the class, when two neighboring carbons, next carbon, if the halogen is attached to the next carbon, what it is called as? The beginning of the class I told. If the two halogens means it is dihalide. It is attached to next carbon means it is vicinal dihalide. What is the name of this compound? 1, 2. So 1, 2. How many bromine is there? 2. Dibromo. 2 carbons means ethane. 1, 2. Dibromo ethane. Can you do for propene? CCl4. So what I will get here? Here this side you should not add. Here double bond is present, so here you cannot add. Wherever single bond is present, so there you cannot add. So where double bond is present, there only you should add the chlorine. So one chlorine you should add this side, and another chlorine you should add this side. Don't add here. Okay. Between the single bond you should not add the chlorine. Wherever double bond is present, there only you should add the chlorine. Okay. So what I will get? CH3 CH, one Cl will be added this side. Double bond will change into single bond. CH2 Cl. What is this one? This is again two halogens are attached to the next carbon. This is also a vicinal dihalide. Vicinal dihalide. What is the name of this vicinal dihalide?
1, 2.
Here this side, from this side you have to number. So 1, 2 dichloro. 3 carbons means it is propane. 1, 2 dichloropropane. Okay. So always when you add halogens to alkenes, you will always get vicinal dihalides. What you will be getting? Vicinal dihalides. Okay. Okay, next we are going to study about addition of hydrogen we have completed, addition of halogens we have completed. So the third one, addition of hydrogen halides. Addition of hydrogen halides. Hydrogen halides means what? Hydrogen and halogen. For example, HCl. HCl means what? H is hydrogen, Cl is halogen. So like this compounds, when we add to alkene, what is going to happen? Okay. So take down. First with ethene I will write CH2 double bond CH2 plus HCl. What I will get? Hydrogen will be added to one carbon and chlorine will be added to another carbon. So what I will be getting? If hydrogen is added to this carbon and chlorine is added to this carbon, what I will be getting? CH2, one hydrogen is added. So I will get CH3. In this CH2, Cl is added. So CH2, Cl. So what is the name of this compound? Chloro, 2 carbons means it is eth. So chloroethane. Okay. So suppose if I add chlorine to the first carbon and hydrogen to the second carbon. This is also possible, yes or no?
Yes, sir.
Chlorine to the first carbon and hydrogen to the second carbon. What I will get? Here I will be getting CH2Cl. Double bond will change into single bond and this CH2 will change into CH3. So again what I am getting? CH3, CH2Cl. Here also it is CH3, CH2Cl. Here also in the reverse direction if I see it is CH3, CH2Cl. So this is also chloroethane only. Okay. So whether if I add like this or if I add like this, I am getting the same product. Okay. So if the alkene is giving the same product, okay, if the alkene is giving the same product, we will call that alkene as symmetrical alkene. What we will call it as? We will call it as symmetrical alkene. Why it is called symmetrical alkene? Because in whichever way we add this hydrogen and halogen, we are getting the same product. Okay, in whichever way we add the hydrogen and halogen, we are getting the same product. So it is called as symmetrical alkene. Okay. Now let us see the example for an unsymmetrical alkene. For example, if the alkene is like this, okay, and to this alkene I am going to add HBr, hydrogen bromide. Okay, so first what I am going to do, always I will be adding between the double bonds. So first what I am going to do is hydrogen I am going to add this side and bromine I am going to add this side. So when I add hydrogen here and bromine here, what I will be getting? CH3, CH, hydrogen I have added, so it will become CH2, double bond will become single bond, and then to this CH2, Br will be attached. Okay, and suppose now bromine I am adding to this carbon and hydrogen I am adding to this carbon. If I add bromine to this carbon and hydrogen to this carbon, what I will be getting? CH3, CH, bromine if I add here, it will become like this. Double bond will become single bond. CH2, I am adding one hydrogen, so it will become CH3. So what are the two types of products that are formed? This is bromo. 3 carbons means propane. Bromo-propane. What is the position of bromine? When you number from this side, the position is 1. So it is 1 bromo-propane. What is the position for this one? It is 2 bromo-propane. Now, which product will be the major product? This is propane. Here it is propane, single bond. Okay. So now, which will be the major product and which will be the minor product? Which product will be formed more and which product will be formed less? That, for finding out that, I am going to teach a separate concept. Okay. After teaching that concept, you are only going to tell me which is the major product and which is the minor product. Okay. As I was telling, so which is the major product? For finding out, I am going to teach one concept. So that rule was found out by a scientist called as Markovnikov. Okay, so the rule is called as Markovnikov's rule. Markovnikov's rule. Okay, so with the help of this rule only, you will be finding out which is the major product and which is the minor product. So what is the rule? Okay, the rule states that the negative part of the adding molecule gets attached to the carbon with less number of hydrogens. Gets attached to the carbon with less number of hydrogens. So the negative part of the adding molecule. So which molecule we are adding here? We are adding HBr. In HBr, which is the negative part? H plus is the positive part and Br minus is the negative part. So what is this rule telling? The negative part will get attached to the carbon with less number of hydrogens. So there are two carbons. One carbon is having only one hydrogen. Another carbon is having two hydrogens. So this negative part Br will attach to the carbon having less number of hydrogens. So which carbon it will get attached? It will get attached to CH. So if Br gets attached here, you will get this product 2-bromopropane. So this 2-bromopropane will be the major product and this will be the minor product. Okay, understood. So we have to decide which product is major or which product is minor in this hydrogen halide addition based on this Markovnikov's rule. Okay. Based on this Markovnikov's rule. Okay, so this is the major product and this is the minor product. Why this is the major product and why this is the minor product? Why this product is forming more? Why this product is stable? For that we are going to study the mechanism. Okay, we are going to study the mechanism. So I am going to take this molecule CH3CH double bond CH2 plus HBr. So how this HBr will divide? It will divide into H plus and Br minus. Okay, it will divide into H plus and Br minus. Now when this H plus alone is added to this CH3 CH double bond CH2. So I am going to consider two types of things. H plus first I am going to add this side and H plus next I am going to add this side. So if I add this H plus this side, what I will get? CH3 CH, one H plus if I add it will become CH2, double bond will change into single bond, then CH2. Carbon should have how many bonds totally? 4 bonds. This carbon is having 4 bonds, this carbon also is having 4 bonds, but this carbon is having only 3 bonds, so it will get a positive charge. So if the carbon is having a positive charge, it is called as carbocation. We already studied this. Yes or no? Now this is one type of product. That is, when I add this H plus this side, I will get this carbocation. Suppose if I add this H plus this side, if I add the H plus this side, what I will get? I will get CH3, single bond CH, double bond will change into single bond CH2 is there, again one more hydrogen I am adding CH3. So this carbon is having 4 bonds, this carbon is having 4 bonds, but this carbon is having only 3 bonds. So this carbon will get a positive charge. So this is a carbocation. What is the difference between these two carbocations? What is the difference between these two carbocations? This is the primary carbocation and this is the secondary carbocation. We already studied the stability of carbocations in the previous lesson. Yes or no? Which carbocation will be more stable? Tertiary carbocation is more stable, then secondary carbocation is more stable, and which is least stable? Primary carbocation is least stable. So this is secondary carbocation, this is primary carbocation. So in this two, which will be more stable? Which carbocation will be more stable? The secondary carbocation only is the stable carbocation. So bromine will get attached. Bromine is what? The negative part will get attached here and this product will be the stable product and it will be the major product. So if bromine gets attached to this carbocation, what I will get? CH3, CH, Br, CH3. So if it gets attached here, what I will be getting? This one you can make a note in the rough column. So here if bromine gets attached, we will be getting CH3, CH2, CH2, Br. So this is the stable carbocation. So the product which is obtained from the stable carbocation will be the major product, and the product which is formed from the unstable carbocation, that will be the minor product. Okay, so this is how you should decide the products. Clear? Understood? So this negative charge will go and attack this positive charge in both the cases. Understood how this product is formed, what is major product and what is minor product? So with the help of Markovnikov's rule, we will be finding out. Okay. The next concept is anti-Markovnikov's rule. Again, it is coming under the same heading only, anti-Markovnikov's rule. In that, they will be telling this is the major product and that is the minor product. So how this will become major product and that will become minor product according to anti-Markovnikov's rule. For the different mechanism we have to study, that we will study in the next class.